Hello, I am Lesha from Team 7, and in this video we will explain the three branches of electricity. First, let's start with electrostatics. Static energy is a surface phenomenon that is generated when two or more bodies come into contact and separate again. This action results in a separation or transfer of negative electrons from one atom to another.
Hello, my name is Salvador Sabdi Medina Piña, and I will talk about electrodynamics. Electrodynamics is a branch of electromagnetism that deals with temporal evolution in systems, which electric and magnetic fields interact with moving charges. So, we have two kinds of electrodynamics. We have the classical and the quantum. The classical electrodynamics, or CED, at first, Albert Einstein developed the theory of special relativity through an analysis of electrodynamics. And it was believed, therefore, that Maxwell's equations were not correct, and the true equations of electromagnetism contained a term that would correspond to the influence of the light ether. Next one, we have the quantum electrodynamics, or QED. As its name suggests, is the quantum version of electrodynamics. The quantum field theory describes that the electromagnetic field interact in terms of photons exchanged with charged particles in the style of quantum field theory.
Electromagnetism is a branch of physics that deals with electromagnetic force that occurs between electrically charged particles. The electromagnetic force is one of the four fundamental forces and exhibits electromagnetic fields such as magnetic fields, electric fields, and light. The electromagnetic force is a type of physical interaction that occurs between electrically charged particles. It acts between charged particles and its combination of all magnetic electric forces. The electromagnetic force can be attractive or repulsive. Electromagnetism is a process where a magnetic field is created by introducing the current in the conductor. When a conductor is electrically charged, it generates magnetic lines of force of conductor.
My name is Diego, and I'm going to make the Faraday's cage experiment. We are going to use a piece of plastic, a balloon, a straw, and liquid soap. First, what we're going to do is put the liquid soap in the piece of plastic. We are going to pour it all over the piece of plastic till it's full of liquid soap. Then, with the straw, we are going to take a little bit of liquid soap and make a bubble with the soap. Then we are going to use the balloon and we are going to make friction with our hair. As you see, the energy is now in the balloon and we can move. I don't know if you can see it, but it moved and it popped. This is the experiment. But what I'm trying to explain is the Faraday's cage experiment, not the friction experiment. What I'm trying to talk about is about this. When you have, sorry for the cut, in the other video you could not see the bubbles. In this experiment, the Faraday's cage experiment, there are two bubbles, one inside of the other. And as you can see, if I put again the balloon against the bubble that is outside, it's moving, but the one that is inside isn't. This happens because the bubble that is outside is acting like a Faraday's cage. Up next, my partner is going to explain the experiment with other words.
Hello, I'm Miss Olvera, and I'm going to explain you a little bit more the experiment that my partner Diego just shown. When we charge the balloon with static electricity, what happens is that Rubinin transfers the electrons from the balloon to the other material. This generates an electrical charge on the balloon, which stays that way for a while because it is made of plastic. When we bring closer the balloon to the soft bubble, the balloon attracts it. This is because in the water there are ions and electrical charged particles that are attracted to the charge that the balloon also has. In the second test that Diego carried out in the video, we have two soft bubbles and we see that only the outside bubble moves and not the internal one. To put it simply, this is because the outer bubble has a similar effect to the Faraday cage, in a way that prevents the electrical charge of the balloon from acting in the inner bubble. With this project, we explained the branches of the electricity, and we made an experiment that could be easy to explain and understand it. We are the Team 7 and thank you for your attention.